Okay, here's one of these big problems. This is taking the ideal gas law, the combined gas laws, the Dalton's laws of partial pressure, all the concepts you learned in the gas law in the gases chapter, and bringing back in all of the stuff that you had from chemical reactions and stoichiometry and tying it all into one problem. This is a gas collected over water type of reaction where you've got zinc reacting with hydrochloric acid and it forms zinc chloride and hydrogen gas. The reason that we tell you those things is because you have to write a reaction. And so you have to be able to write down all these formulas. And in order to be able to do that, and in addition to be able to do that, you need to be able to balance the equation. Once you have a balanced equation, you have to notice that it says that it's collected over water. And that means something very specifically. So what we're saying is that the hydrogen gas is collected in a vessel and the reaction is performed in water. And so that means that there is actually a mixture of gases in what's collected. The mixture is both water and hydrogen. And so that means that the total pressure is the sum of both hydrogen and the partial pressure of water. So the partial pressure of hydrogen plus the partial pressure of water, and the partial pressure of water is its vapor pressure. Now, ultimately, we have to figure out how many grams of hydrogen are collected. So what that means is we need to know the pressure of hydrogen, the partial pressure of hydrogen, in order to calculate the number of moles, in order to convert that to grams. So there is a lot of work to do. So we need to figure out the partial pressure or the vapor pressure of water at 30 degrees Celsius. And how do you do that? We're going to have to look it up, or in an exam or quiz, you'd be given a table and you'd look it up in that table. And what you find is that it's 31.8 torr. Now, remember that torr and millimeters of mercury are the same. So up here in the problem, you can change this to torr, or maybe even in your problem set, it's already changed to torr. So it's the same thing. 1 torr equals 1 millimeter of mercury. All right, and so now that we have that vapor pressure of water at 30 degrees Celsius, we could start to take care of this problem. We know from the ideal gas law that the partial pressure of hydrogen times the volume equals the number of moles of hydrogen times R times T. And so if we rearrange the equation, we know that we need the partial pressure of hydrogen times the volume divided by R divided by T. Now, you're given the volume, 378 milliliters. You're given the temperature, 30 degrees Celsius. And so our job is to figure out this partial pressure of hydrogen. So how do we do that? The partial pressure of hydrogen is equal to the total pressure minus the vapor pressure of water. So in torr, it's 925 minus 31.8. And so we get the partial pressure of hydrogen is 893.2 torr. Now, of course, it needs to be in atmospheres, so I can use the gas law constant that I'm familiar with. And so dividing by 760, I get 1.18 atmospheres. Phew, a lot of work. So I've got my partial pressure of hydrogen. And so now I can put that into my ideal gas law equation to calculate the number of moles of hydrogen. So 1.18 atmospheres, convert that 378 milliliters to liters, convert that temperature 30 degrees Celsius to Kelvin, that's 303, put in my gas law constant, and I can put this into my calculator and I get 0.179 moles of H2. And I got one more step. I have to convert H2 in moles to H2 in grams. And so I have to use the molar mass to do that. 2.018 grams of H2 is equal to 1 mole of H2. And so the final answer is 3.62 grams of H2. And so if you can do a gas law problem like this, then not only have you mastered a lot of the concepts in the gas law chapter, but you really are very comfortable with stoichiometry and all of the other conversions that we've done in the course. Okay, that's it.